So here we start. I think there are only two slides left for this chapter to get over. Let's start with the circular motion. We have done all the linear motions, right? Now we are going to do the circular motion. Please start.
A body is said to be in circular motion when it rotates about a fixed position. In
Which
circular,
point it is?
in circular motion, the velocity can never be constant, but the speed of the moving body can be constant.
Then,
A body moving in a circular path at a constant speed is said to be uniform circular motion.
and it is notified as V
Velocity
is
is
equal
equal
to
to 2 pi
2
r
pi r
divided by t.
upon T. Fine. Now what is the fixed point over here? There is the fixed point. You can see this is dot. Can you see the dot in the center? This is the fixed point. So the body is moving around a fixed point, right? The velocity can never be constant, but the speed of the moving body can be constant. Can any of you explain this? This is circular motion, remember that. Tell me. So I'm giving you as a homework. Think it over. I'm not going to give you the answer to this. So we can discuss about it tomorrow. Okay, this is a task for you. Find it out. Why did I ask you this question? That velocity can never be constant, but the speed of the moving body can be constant. I can give you one tip. Should I ask you one question, children?
Yes, ma'am.
Okay. Only thing is, the difference is only about the quantity. Which one is scalar and which one is vector quantity? When you find out that, you will get the answer. Now, I have given you the hint. I've given you tips. One is scalar quantity and the other one is vector quantity. You understood now? Hello?
Okay,
Out of
ma'am.
vector and speed, one is scalar quantity and the other one is vector quantity. And you will get all the, I've already taught you all these things, remember that. So when you go through the chapter once again, you will get the answer. That why velocity can never be constant, but speed is always constant. You understand? Hello? Did you
Yes, ma'am.
understand? Okay.
Yes,
Now, when
ma'am.
I'm talking about a uniformity, whenever I talk about uniformity in velocity, uniformity in speed, uniformity in acceleration, I have to take it that everything is happening at a uniform pace. So if I'm talking about a circular path, then the speed has to be constant, then only the circular motion will be uniform. You understand? So I take it for granted that the speed is constant, so a body is said to be in uniform circular motion. And we know that velocity is equal to, what is the formula of velocity, beta? Distance upon time. You know that, right? Yes or no? What is velocity, beta? Answer me fast. Velocity is equal to, boys, can you hear me? Hello? Boys, can you hear me? Hello, boys.
Yes.
Yes, okay. So velocity is equal to distance upon time. You know that, right? So if I start measuring from here, I go from here, then again I come back, right? So here, do I take the circumference or the area?
Circumference
Circumference. What is the circumference?
means the boundary.
Yeah, so it is 2
Diameter.
pi r. Exactly. Fence or this boundary is it either if at all I want to find out, okay, let's do the fencing. So what will I do? I will take the area or I will take the circumference. I will take the circumference, right? I'm not taking all this inside. This is not required. I require only the outline. So what I will take? I will take the circumference. And what is circumference? It is 2 pi r. So what is circumference? 2 pi r divided by t. So this is becoming your velocity. Have you understood?
Yes, ma'am.
Yeah. So this is the uniform circular motion. Okay. So the body is moving like this. Can you see this arrow? The body is moving like this. These are the trajectory motion. Can you see this? These are what you call as tangent in maths. These are called tangent in maths. So this actually is showing you the velocity. Okay? It's the same thing. We can do it again. Yes, please read. Please read. Please read better. John, Sayed, Saheem, any of you please start reading.
Circular motion. The motion of a body in a circular path is called circular motion. Uniform circular motion. If a body moves in a circular path, uniform speed, its motion is called uniform circular motion. An uniform circular motion is accelerated motion because in a circular motion, a body continuously changes its direction. The circumference of a circle of radius r is given and
2 pi r.
2 pi r. If a body takes time t to go once around the circular path, then the velocity v is given by v is equal to 2 pi r upon t.
So I hope this is more of a detailed account as compared to the earlier slide. So here you will observe uniform circular motion is accelerated motion because in a circular motion a body continuously changes its direction. You agree? See, because it is changing its direction every time, every moment. See, here it is straight line, here it is changing its, see, because it is in a curved path. It's continuously changing its direction. You understood? So when it is changing its direction, so it's a velocity is changed. It's in an accelerated motion. You understand? If you keep on turning in a circular motion, you're changing its direction and your accelerated motion. The motion cannot be uniform. It has to be accelerated motion. So it is a circular motion. So it becomes uniform circular motion when you are changing the path or changing the direction. For example, this is the central part and this is the body. And how the body moves. This is the second. This is the first and this is the second. This is how the body moves in a circular path. Over here, same thing. Can you see over here? The direction is changing every moment. The direction is changing. Okay, so the velocity is also changing. So we come to the end of this chapter. Uh, if you have any difficulty regarding this topic and the earlier topics, you can ask. One of you please take up the charge of explaining circular motion then, if you have understood. Yes? Boys, you have to answer me. I'm asking certain questions. Am I audible? Boys, can you hear me? Hello? Can you hear me, beta? Hello? Hello? Boys, can you hear
Yes,
me?
yes, ma'am.
Yeah, but why is it taking so long? I mean, I've been asking you since ages, I find. 10 odd hellos and then I get the answer of fuse. Why? Is it taking time? Hello?
No, ma'am.
Okay, then answer me fast, beta. Okay, can you explain the circular motion in your own words? Yes? Doesn't matter if it goes wrong. At least try.
A body, ma'am, which moves
Yes? Which moves in a circular part. Then,
ma'am, if a
hello?
body moves in a consistent circular path with the
In a
same
constant.
uniform
Yes, in a
constant
constant circular. Then,
path with the same uniform speed, then its motion is called uniform circular motion.
okay, so we understand that it's uniform speed, but the velocity is not uniform. Remember that, right? So this is your homework. You have to let me know why it is so. Okay? Hello? Understood now?
Yes, yes, ma'am.
Okay. Because if it is not having uniform velocity, that means even acceleration is different. What do you agree with me? If the
Yes.
velocity is changing, I told you already the velocity is changing. That means the acceleration is also changing because acceleration is the difference in velocity. You understood? Hello? B minus u upon t. Acceleration is equal to b minus u upon t. And we know the velocity is changing. That means acceleration has to change.
Yes, ma'am.
Okay? And but speed will not change quantity altogether. Okay. Now what we'll find? How do you define? Yes. Now you define. Be first. What is the formula of velocity? What is the formula of velocity? It is distance upon time. What is the distance over here?
2 pi r.
2 pi r. So velocity is equal to 2 pi r upon t. That's what we got. We got the formula of the circular motion. Any problem?
No.
So this is it. So try to, try to make it simple. Nothing is difficult. Do you find anything, any difficulty? Was there any problem in this topic? Yes? It was simple, isn't it? Okay. Any problem to anyone else? Boys, all of you have understood?
Yes, ma'am.
Please. Yeah, Sahim, only you are answering. The rest of them?
Ma'am, I don't know about them. They are busy, I think so.
Yeah, I think they are busy. Fine. Anyways, okay, we start with the next chapter now.
Yes, ma'am.
The gravitational force. By mistake, I put lesson number 9. I will just change it. It has to be lesson number 10. So these are the people who worked on force of motion. We had already done the Newton force of motion. I think you should know that. That's done by Sir Isaac Newton. This one is Sir Isaac Newton, this person. Okay? And this person is Kepler. He is Kepler. He has worked on gravitation. Johannes Kepler. Yes. We'll do line by line, okay? And if you can explain, well and good. If you cannot, then I will explain. Okay? Nothing difficult. There's no difficulty as such in understanding the slides. But still, I feel if you take part, it will be better. Yes, Sahim, start.
Okay, ma'am. Gravitational force of the Earth or gravity. A force is necessary to produce motion in a body. A body dropped from a height falls towards the Earth. It indicates that the Earth exerts a force of attraction called gravity on the body. In
Okay,
fact, the
just,
Earth attracts.
just a moment. Just a moment. Now we know that if I want to move a body, movement of a body is called as motion. Okay. Now, do you think a body will move on its own?
No, ma'am.
Do you think
Force.
a body will move on its own? No. So what I have to apply? What I have to apply?
Force.
Force. Simple. So it's a must. Force is a must for the body to move or to come into motion. For example, we take this is a ball and it's coming down, right? It's falling down from a height. It's a ball, it's falling down from a height. It's coming towards the earth. Why? That means earth is pulling it, isn't it? The earth is pulling it down. So this is earth. Earth is pulling it down, which is known as gravity. So what is applied on the body? Gravity is applied on the body, and with that, it is coming down on the earth. Understood? Understood or not?
Yes, ma'am.
Okay. Now start.
In fact, the Earth attracts all the objects towards its center. The force with which the Earth pulls the objects toward it is called the gravitational force of the Earth or gravity. The gravitational force between the Sun and the Earth keeps the Earth in form in uniform circular motion around the Sun.
Fine. Now, actually, the earth is attracting all the objects which is available on the earth, all the objects towards the center. Now, what you may be asking me a question, what is the center of the earth? This is the center of the earth. This is earth. We know the planet is round. This is the center of the earth. That is called as core. What it is? Core. It is magnetic. You know that. The core of the earth is magnetic, right? So all the objects are moved towards the earth due to the pull which is done by the center of the earth. Now, this force by which the earth is attracting all the objects towards it, it is called as gravitational force or gravity. Now, there is also a gravitational force between the sun and all the planets. And that's the reason that these planets are moving in an orbit, in a fixed orbit. They are not colliding. Now, if it would not have been fixed orbit, don't you think all the planets would have collided with each other? What do you say? Hello? What do you say, Vita?
Yes, ma'am.
Simple. If, like, let's talk about our highway roads. If there are no dividers and if there is no fixed position or fixed place for the vehicles to move, don't you think they will collide to each other? Yes,
Yes,
there's a
ma'am.
fixed path. Similarly, planets have got a fixed path around the sun and they move in that typical orbit. They don't shift from their place. They do not shift the path. Why? Are we going there to fix the path, beta? No. It is all done naturally by the magnetic force, by the gravitational force between the sun and the planets. And we are one of the planet. Earth is one of the planets, right? So this is the reason that all the planets are in a circular motion around the sun. Now you see that what is this gravitational force or the gravity is responsible for, one by one. If you can explain, well and good. First one is, say, yes, please read it up.
Okay, ma'am. The gravitational force of the Earth, or gravity, is responsible for holding the atmosphere above the Earth, for
Yes.
the rain falling to the Earth, for the flow of water in the rivers, for keeping us
Firmly.
firmly on the Earth, for the revolution of moon around the Earth, etc.
So you can see all these activities. Someone's mic is on. Thank you. All these activities, for example, we have the atmosphere around the earth, right? We are covered or surrounded by a blanket which is known as atmosphere. This atmosphere is actually due to the gravity. The rain is coming towards the earth. It's again the gravity. The rivers having water which is flowing. This is again due to gravity. We are not floating. We are not flying. We are on the earth. We are moving on the earth. We are steadfast on the earth. You understanding? Otherwise, we will float if there is no gravity. So we can move on the earth due to gravity. And the moon, the satellites, which are moving around the earth or around any planet, is actually due to the gravitational force. I think things are quite clear. If there would not have been gravity, this would not have existed. It's not possible then. Due to gravity only, all these things are possible. Any problem? Boys, any problem, beta? Hello?
No, ma'am.
Yeah, understood? What is gravity? We studied in this slide. What is gravity? And what are the effects of gravity? These two things we learned in this slide. Okay.
Yes,
There's another thing which happens due to the gravitational force that we are going to read now. Start.
the gravitational force between the Earth and the Moon causes tides in the sea. Think why tides are high during full moon and new moon day.
Okay. I will ask you some questions also right now. Now there's another effect of gravitation which is observed on the earth is occurrence of tides. Now what are tides? The waves which come very high on the coastal areas or on the sea coast or on the beaches of sea. When you get huge waves lashing onto the coastal areas, that is called as tides. Generally, the tides occur on the full moon day and the new moon day. And at that time, fishermen are not allowed to go into the sea. You should know that. They may get drowned, okay? Because that time it becomes very violent. The sea becomes very violent. Because the gravitation is high. That's what is told. We get two types of tides. One is spring tides and the other one is neap tides. Okay? And we get two tides every day. When the tides, when there's a high tide, it comes on the coastal area. When there is a low tide, then the coastal area or the region near the coastal area, it gets exposed. So you can see rocks exposed of the sea. Understood or not? And you should also know that in the sea we get lots of vegetation, lots of plants, and there are many animals which requires this sort of duration, exposure, as well as covered by the water. If it is not there, then they may die. So they are adapted to this kind of situation, completely covered with seawater and then exposed for certain 2 or 3 hours duration every day. So this is what tides do. You understand now? Hello, hello.
Yeah, ma'am.
You understood? So for some time they completely cover the coast, and for some time they totally get exposed. So water recedes, it goes inside. That is called low tide. And when there is high tide, the coastal area gets covered with the seawater. So tides are also due to gravity. So I may be having different type of slides for the same matter, just for the revision purpose I've kept it. So don't mind if I'm repeating it again and again. Yes, start. Start.
Gra- Gravitation. Gravitation is the force of attraction between two objects in the universe. Gravitation may be the attraction of object by the earth. If a body is dropped from a certain height, it falls downwards due to earth's gravity. If a body is thrown upward, it reaches a certain height and then falls downward due to earth's gravity.
Okay, that's it. We already know that the gravitation is the force of attraction between two objects. Now, what are the two objects over here? I can say one is sun and the other are earth. Can I say that in the universe? Yes or no? Even I can say ball and earth. Can I say that?
Yes, ma'am.
It's in the universe, right? We are all in a part of universe, isn't it? Universe is the whole world. Okay? So, what are we talking about? We're talking about the attraction between two objects found on the universe. Now, that can be attraction of objects by the earth. That's the first point that we are going to take care of is that any object which is falling on the earth, it falls downwards. It doesn't go up. If I allow it to free fall from a certain height, it won't go up. It will only come down. Why? Due to Earth's gravity. For example, this is the ball. I, I allow it to fall, it comes down. But if I allow it to go up, that means I am throwing it up. This is the ball over here. I'm throwing up the ball. It goes to a certain height, then it stops for a while, and then it comes down. Have you observed this? Do you think if you hit a ball, it keeps on going up and it is lost, it vanishes? Is it like that? It doesn't come down? It reaches a certain height and then it comes down. Why does it come down? Again, the same thing due to Earth's gravity. Yes? Hello? Have you understood, all of you?
Yes.
Yes? Okay. Now we come to the second point. What is the second point? Yes, read. Yes, please read.
Okay, ma'am. Gravitation may be the attraction between objects in outer space, attraction between the Earth and the Moon, attraction between the Sun and the planets.
Do you agree with it?
Yes, ma'am.
We have already studied. So, this next gravitational factor which is working in outer space is how come all the planets are moving in a trajectory motion around the Earth? How come? Okay? So, this is due to the attraction or to say gravitational force between the Earth and the Moon. That's how the satellite is moving around the planet. And the attraction between the Sun and the planets. That's how all the planets are moving around the Sun. The revolution of planets around the sun and the revolution of satellites around the planets. This is all regulated by, this is all defined by the gravitational force in the universe. Any problem? Any problem?
No, ma'am.
The force that we are going to study now is the centripetal force. This is what I have taught you in 8th standard. Remember that. Two forces I have taught you. One is centrifugal force and the other one is centripetal force. Here, centrifugal force is not useful, so we are taking the centripetal force. Let's define. Start.
When a body moves in a circular path, it changes its direction at every point. The force which keeps the body in the circular path acts towards the center of the circle. This force is called centripetal force. If there is no centripetal force, the body will move in a straight line straight,
Tangent.
tangent
Tangent.
tangent to the circular path.
Understood or not? Simple. This is what we had done earlier in the first slide. What it says that when the body moves in a circular path, okay, it changes its direction. See, everywhere it is changing its direction. Can you see this? Everywhere because it's moving round. If it's in a straight line, it is not changing its direction. And what they have said is a tangent. So these are tangent. Can you see this? These are tangent. All these are tangent. So if there's no centripetal force, the body will be straight line because there's no tangent. But when it is in circular motion or circular line, it has to have a tangent. It is changing its direction at every point. Okay? And it is moving towards the center. Can you see that? See, it's all moving towards the center. It is not going away from the center, but it is moving towards the center, and hence it has become a circular path. This force, which is moving towards the center, it is called a centripetal force. And the force which is moving away from the center, it is called a centrifugal force. You understand? No.
No,
So, what all these forces are moving towards the center. Got it? Hello? The circular motion that we learned earlier. Circular motion, remember? B is equal
yes,
to pi r upon t.
but this I'm not understanding.
Okay. Just remember the last chapter, force, what we did the circular motion, that you only defined B is equal to 2 pi r upon t.
Yeah,
What is that motion? That is centripetal. The circular motion was centripetal. Same thing we are observing here. The planets moving around the sun, the satellite moving around the sun. What is this? It's all circular motion.
Okay.
Same thing applies over here. But now, what force we are working on? Gravitational force. Do you understand now? The basic remains the same. A new force that we are working on right now in this chapter is the gravitational force. So the aspect becomes the gravitational force, but the basic remains the same. Understood or not?
Yes, ma'am.
Still confusing?
No, ma'am.
Because what they said that if there's no, these are tangents. See, you see over here, one tangent is here, is moving here. One tangent is here, one tangent is here. Now, if I open up this circle, it becomes a straight line. Do you agree? If I
Yes, ma'am.
unwind, it becomes a straight line. Then there is no tangent. Do you think there's a tangent in the straight line?
No.
Tangent is always in the circular line. Always remember that. Okay?
Yes, ma'am.
In each slide, it's same, gravitation only, but you will learn lots of new things. You start gravitation. Start.
Gravitation. Earth attracts everything toward it by an unseen force of attraction. This force of attraction is known as gravitation or gravitational pull.
So you agree with it? Cannot see the force, but we feel the force. What did I say? We cannot see the force, but we feel the force. We also can see the force when I see a ball which is thrown up, is coming down. I can see that. I can see that, isn't it? When I throw something, it comes down. I can see it. But me, myself, when I'm falling from something, from top, I can feel the force. I'm pulled down. I'm on a swing. I fall down. I'm pulled down. You're on a slide. Hello, you're on a slide. You're sliding down with a force. Can you feel the force? Yes or no? Can you feel the force on you?
No, ma'am.
You don't feel the force when you're sliding down? You're pulled with a force. You don't feel it with a? I'm talking about slide. If you're on a slide, you know what is slide? Not
Okay,
steps.
yes, ma'am. I'm
Yeah,
getting that.
slide I said, not steps, slide. When you slide down yourself, it's a game. Don't you find when you're coming down with a force? It's all due to gravitation. So what does universal law of gravitation suggest? Let's see. Read. Hello.
Yes, ma'am.
Yeah, read please.
Universal law of gravitation. Every object in the universe attracts other object by a force of attraction called gravitation, which is directly proportional to the product of masses of the object and inversely proportional to the square of distance between them. This is called law of gravitation or universal law of gravitation.
What
The
it
distance
is? What is
universe
if a mass of one object is m1 and the other object is m2. So what will be? It will be m1 into m2. That is directly proportional is equal to inversely proportional to the square of distance between them. If the square is d, then it becomes d square. So m1 m2 upon d square will be the law of gravitation or universal law of gravitation. Is it understandable? Is it understandable? It should look like m1 m2 upon d square. This is going to be the force of gravitation. Please read.
The distance is covered between the centers
Considered.
is considered between the centers of the object. Suppose there are two objects having mass m and m
Say
respectively,
capital M and small m.
small m respectively. The distance between their centers is equal to d. The force of attraction is F. Now,
Ma'am, time up.
Yeah, it's time up. Okay. So we continue tomorrow.